Hi, warm welcome to AIMS University Malaysia. Myself, Dr. Sridevi, here to deliver you a knowledge about stereoisomerism. Stereoisomerism. From this session, you will gain the knowledge regarding the definition and types of stereoisomerism. Coming to the definition of stereoisomerism. Stereoisomers have the same structural formulas, but they differ in their spatial arrangements. There are two types of stereoisomerism: geometrical isomerism and optical isomerism. In stereoisomers, the bond structure is the same, but geometrical position of atoms and functional group in space differs. This class includes enantiomers, where different isomers are non-superimposable mirror images of each other, and diastereomers when they are not. So, stereoisomers are of two types, enantiomers and diastereomers. Diastereomers are again divided into two types, that is, cis-trans isomers and conformational isomers. Cis-trans isomers have restricted rotation within the molecule, whereas conformational isomers, which can rotate about one or more single bonds within the molecule. Although conformers can be referred to as stereoisomers, they are not stable isomers, since the bonds in the conformers can easily rotate, thus converting one conformer to another, which can be either diastereomeric or enantiomeric to the original one. While structural isomers typically have different chemical properties, stereoisomers behave identically in most of the chemical reactions, except in their reaction with other stereoisomers. Many biomolecules exist as stereoisomers. They are non-superimposable mirror images of one another. They are called as enantiomers. Here you can see an example for enantiomers. L-glyceraldehyde is non-superimposable mirror image of D-glyceraldehyde. Sometimes it's very difficult to pick out the stereoisomers. Use your hand as an example. Your right hand can be superimposed on someone else's right hand with no problems. When you arrange your hands in this way, the fingernails, palms, thumbs, all are on the same side. Now, try to superimpose your right hand over your left hand. Notice that your left hand is a mirror image of your right hand, so you cannot superimpose. Here you can see how your left hand and right hand look like. Your left hand is exactly the mirror image of your right hand. When an object cannot be superimposed on its mirror image, the object is said to be asymmetrical, or sometimes it may be chiral. The presence of a single chiral carbon in biomolecule or biological molecule gives rise to stereoisomerism. If a carbon is attached to 4 different groups, it is called chiral carbon. If any of the 2 groups are identical, it is not a chiral carbon. There is no rule that a molecule or a compound should contain only one chiral carbon. There are many compounds which have more than one chiral carbon. Here you are given with an example where there are 2 carbons which show the property of chirality. The maximum number of stereoisomers for a molecule can be given by the formula 2n, where n is the number of chiral carbon atoms. So, in this example, there are 2 chiral carbons. That means we can get 4 stereoisomers for this molecule. So, any molecule containing chiral carbons have non-superimposable mirror images. Molecules whose mirror images do not superimpose are considered as stereoisomers. The mirror images of stereoisomers are called enantiomers. Stereoisomers that are not mirror images of one another and are non-superimposable on one another are called as diastereomers. Thank you for listening about stereoisomerism.